This is where we're at now. The prereq, if there was ever a prerequisite course, it used to be for this class, the prereq would be an intermediate algebra class in high school. That's probably what they would call it, maybe. For here at SRJC, it used to be called 155. Sometimes they might call it advanced algebra in high school as well. But we don't have a 155 anymore. So the best thing or the closest thing is a 156. Some of you may have had that in the spring, as soon as the spring. My assumption is all these, like the word function right here, that's not foreign. That should not be foreign at all. If it is, then we need to talk, because I need to find out why it's foreign, to you, so we can assess if you're in the right class or not now that we're second week in. So functions, we're going to talk about functions. That's a formal definition. Right here, for every input, there's exactly one output. For every x value, there is only one y value. Okay, functions, let's see. My intermediate algebra class, we would say, okay, y equals mx plus b, for instance, in beginning algebra. So if I had y equals 3x plus 2 in beginning algebra, that's a line. Well, it's also a picture. Okay, first of all, it's a line that does not go up and down. It's not a vertical line. So it's got some kind of a tilt to it. Any picture that what we call passes the vertical line test, a circle, is not a function, because a line goes right through it twice somewhere. So any picture that passes the vertical line test means it only go through once. You can't find any other place that it goes through 2 or 3 or 4 times. That's called a function. That's the picture idea. But here, it just means for every x, I'm not going to get 2 or 3 y's. Here, I'll give you another example. Okay, for every x, do I get only one y? So for instance, if I go x is 2, couldn't y be, let's do 4. If x is 4, couldn't y be negative 2? And couldn't y also be positive 2 to give that true statement? So you've got 2 different y's for that one x. That's not a function. This right here, that equation, is not a function. And functions in your graphing calculator are the only things you know how to graph right now. If I go y equals, everything that's in here, there's an absolute value one right here. And y equals 4 is a horizontal line. Those are all functions. It doesn't do f of x. That's that, I don't know, call it a fancy notation. I don't have it right here. F of x. That's how we pronounce that, f of x. It's a fancy way of saying y. So if I write everything as f of x, then I know I can put it in my calculator and graph the darn thing. So you're going to have some problems. In 1.2, it says, well, pick out the ones that are functions. Pick out the equations that are functions. The pictures will be a lot easier. If you have pictures, you can tell if it passes or not passes the vertical line test. For instance, function or no function? Yeah. No. 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 Yes. The reason why this is yes is because if I take a line, it only goes through it once, where this is a no, it goes through it twice. That's not a function. Yes and yes. See? So picture-wise, easy to identify it's a function or not. Equation, it gets challenging. So the way I'm telling you is if you've got an easy way of getting the y by itself, the equation by itself, particularly don't take square roots of both sides because that's telling me that it's not going to be a function. Or if you see that the degree, does the y have an even degree? Because to get y by itself, you're going to have to take the square root, which means you got a plus minus when you do both sides, a fourth root, plus minus. So what's the degree in the y? 1. So this is a yes. That's just a line. Okay, that's easy to get y by itself. The degree is 1. So when I'm saying if it's got an even degree, it's not a function. Okay, that one's yes. No. Now, if you were to graph this and make a table of values, which you can do, it'll turn out to be one of those parabolas that look like something like this. So it's not a function. If you plotted points to come up with the answer, then you plot points. It's not going to be a function. This one's a yes. Degree is even, so this one's eventually going to be a no. Previous class, your previous class, these should not be unfamiliar. We're just going to add to it. I mean, we're going to revisit it. Your previous class, that kind of function, oh yeah. Polynomial, yes. Quadratic, yes. Quadratic is just a special case of a polynomial. What's the degree of a quadratic function? Anybody want to chime in? What's the degree of the quadratic function? Degree. It's a polynomial. What's the degree of this polynomial here? Anybody have an idea?
Is it squared?
It is. So Rochelle, yeah, it's the degree 2. Polynomials have certain degrees, like linear is a polynomial. It's just degree 1. That's a degree 2. Cubic is another special case of a polynomial, and that would be degree 3, and so on. Okay, radical functions, yes. Trig functions you have yet to do, and we will not do that in this course. Log functions, yes. Rational functions, yes. Absolute value functions, maybe. I don't do those in my 155, and some instructors do. It's not a requirement. So some of you may have, absolute values look like V's. Looks like V's. So I'm not going to check mark that because some of you don't. And exponential functions, yes. So all the check marks has to be familiar in terms of function notation. F of x is not so special. We just maybe F for function, but you can change the letter to G or H. I would say that like in algebra, your first 2, maybe first 3 famous variables that are used, X, Y, Z in algebra. Your first 3 function notation variables, F of x, G of x, H of x. Probably most textbooks do them in that order, but there's no reason why you can't have capital M of x. There's no reason why it couldn't be another letter. I would say we're typically using the variable x. You don't have to. It could be f of h. And then the equation over here would have to be like 2h squared minus h. That's what it have to look like. That's the variable that you're doing. But in this case, I've got a lot of stuff going on. In this case, it says evaluate. this says g of 2, put a 2 in everywhere you see an x. Put a 2 in everywhere. Okay, that means I see an x. So that would be a 2 goes here. That 2 remains. Subtract. Better put parentheses around that x and square it and subtract 2. And then you simplify. So this would be square root of 4, subtract 4, subtract 2, 2, subtract 4, subtract 2, negative 4 if I haven't made a careless mistake. I'm going to show you something. If this is a function, that's graphable. And there's some other wiggly parts. Now notice it looks like it stops right there. Think about it. If I put in like negative 3 right here, that's square root of negative 3 plus 2. That's square root of negative 1, and that's not real. Square root of negative 1, you don't know. A few of you might have an idea of what the square root of negative numbers, say square root of negative 1. Some of you might have prior knowledge to that. I never cover it in an intermediate algebra class. Anybody know what that is the same as? Because maybe that tells me you've had a little background.
Is it I of 1?
It's I, yeah. It's I. And then whoever responded there, can you tell me what the square root of negative 4 is? Maybe you've got a pretty good idea what's. We're going to look at this semester, but it's in chapter 2.
I2?
4i?
2i.
It's 2i. There you go. 2i. Square root of 4 is 2, and the negative means it's going to be I. I for imaginary. But don't worry about that, because right now I've got, and that's what I was saying, that you can't go any farther than that. Now, if I, in my calculator, I have a way of checking this, by the way. A couple different ways. If I go into my table up here, I can look for the number 2. There it is. And it's output. I mean, the y's are the outputs, the x's are the inputs. The x's are the domain. There's another word that should be familiar with you. That's the domain, and this is the range, for instance. You know, that's one way of finding out, hey, when x is 2, what's y? It's negative 4. Like right here. When x is negative 2, y should be negative 2.
Can you please show us how you got to that screen one more time?
Uh-huh. So I'm going to go, after I graphed, there's what's called the table feature right here, blue. Now, if you don't have anything right here, you may have to set up your table. And if you ever want to set up your table, there's a table setup right here. So table setup, you want to do it automatically. You want to make sure these are highlighted, auto. And you can start it anywhere you want. I mean, I can start it at like negative 5. And the increments, that's when it jumps. So it's going to go negative 5, negative 4, negative 3, negative 2, negative 1, and so on. And then I go into table setup, or table set. I can't even say it. Then I go into table. And, oh yeah, see, notice I can't use negative 5, 4, or negative 3 because it's imaginary. So it gives me an error. But Other than that, it gives me everything else. So if I look at like this one here, that would be undefined. That's what you'd say. It's undefined. It's not a real number. You don't tell me it's imaginary. This one here, you'd end up going it doesn't matter what happens over here because that is a problem. So you'd say undefined as of right now, or you can say not real. This one was defined, you know, square root. This was -2. I'm back over here again, +2, and then subtract. So this one's peculiar. I would never have given this kind of problem in a 155, but you guys are the next level up. It's math 25. So a little peculiar. We introduce variables. All you're doing is taking the 3 and the a, and you stick it right where the x is. So 3 and the a is replaced right here, which is where the x, and I put it in every place where there's an x, 3a. And collect like terms if you can't, but I can't. So this is what is called G of 3a. And there's no way of, hey, I'm going to check that with my calculator. You can't do it. Can't do it. Similar, this gets a little more challenging now. I'm going to go the a plus 2. I'm going to put it right there. So I think what I'm going to do is show you a plus 2 is in parentheses. This used to be x. So I'm going to put a plus 2 right here, a plus 2 right there, a plus 2 right there. So a plus 2 goes in the parentheses, and here we go. Parentheses, a plus 2, and there's still a plus 2, and subtract, parentheses, a plus 2, power 2, subtract, a plus 2. And then there's some algebra to do. Algebra. Now, under here, it's the square root of a plus 4. And now this one can get you into trouble. Some of you might say, I'll just put the negative in first before I square it. That's illegal. That's wrong. That's not right. PEMDAS, let's see, parentheses first. No, there's no like terms. Power or exponent a second. You got to do that first before you subtract. You got to do that or before you multiply. So I'm going to leave the negative alone for right now. And then I'm going to write this down twice. Now, a couple of you are going to say, Jeff, isn't that a squared plus 4? And I'd say, you just made the careless or common beginning algebra mistake. My beginning algebra students, when they see like the x plus y squared, a lot of them say, hey, it's x squared plus y squared. That is not correct. Not correct. Not. X plus y squared is, in fact, you write down the parentheses twice, because that's what it says. It's touching the parentheses, write it down twice. Oh, then you FOIL. Then you FOIL. That's correct. So here, I want to write this down twice. So this would be a plus 2, a plus 2. And then now I can go ahead and distribute the negative here and the negative there. Again, some of you are going to think, hey, that's the square root of a plus 2. You think you can bust this up into 2 different square roots. That's not right. Not right. This is just left alone. Okay, leaving the negative out there still for a moment. And now I'm going to FOIL. So that's first, outer, inner, last. And I'm going to collect like terms. Like terms are going to be the middle terms. So first, that would be a squared. Okay, the outer and the inner. That means that's 2a, and that's 2a. That's 4a. Those are like terms, so that's ultimately 4a. And then the last term would be 2 times 2 is 4. Now I can distribute the negative through. Distribute, distribute, distribute. Almost done. Good thing, I'm out of paper, out of room. Okay, minus a squared. And now these are like terms. That's a like term with this one. And then this is with this one. And that's the result of g of a plus 2. In your textbook, you get a few pictures. This type of problem I would not have done in a Math 155 class. So this is for my classes are new. If you ever took my Math 155, you wouldn't see this. You'd understand the domain and range, but using a picture to kind of answer the question you wouldn't have done. So domain are all the x values. And on a picture, it's left to right. Range is all the y values. And that's down to up. So lower to higher. So here, domain. So the question is how far left and right am I going? How far left is this headed towards? That looks like it's negative infinity. And this is going to positive infinity. So here's a little clue for you. Functions. The domain of any function is all real numbers unless you see, and basically these are the equations, unless you see fractions, roots, or logarithms. The domain is always going to be all real numbers unless you see fractions, roots, or logarithms. But I don't have an equation for this, so the best you're going to do is if it's a function and there's no asymptotes, we're going to look in chapter 2 about, chapter 2, I think it is, asymptotes, or there's breaks. When I say breaks, if I saw a picture like that, the domain is not going to be all real numbers. It's going to say from how far to left to here, and then union. I'll talk more about what that union means. Sometimes it means or. And then you pick it back up here, and you continue this way. And interval notation is pretty typical. So the domain on this, there's no breaks. This would be from negative infinity to positive infinity, interval notation. But the range doesn't go down this way forever. The range starts right here because it's always lower to higher. The y value right here, it looks like it's 2. Oh, there's your vertex. It looks like it's 2. And it looks like I get it. So you're going to go smaller 2 all the way up to infinity parentheses. You never put a bracket on parentheses. Now from the picture,
negative 2?
And thank you, because that is negative. I didn't see a negative right there. You're absolutely right. And it's there. Should have paid more attention. So thanks for the clarification or the correction. Yeah, so the lowest is, it turns out that it is -2 right here, and it goes up to infinity. And you put a bracket because there's a solid dot right there. Now the x-intercepts, the best you can do on this image is an approximation. That's the origin. So there's -2, -3, so about -2.7-ish, x-intercept. I can go -2.7-ish. There's no way of doing like an approximation squiggly in, this is an ordered pair, ordered, not an interval. The other one is -4, -5.3 maybe. And the y-intercept is up here. Oh, I don't know, maybe about 14-ish. Y-intercept is up here, maybe about 14. Because there's 12, it misses it. There's 13 maybe, and I'll say 14-ish. The best you can do is an approximation. All right, now your textbook will have images like this, and it'll ask you from the picture, what's f of -4? This is, or was, an x value. -4 is an x value. So I'm going to take my end of my pen right here, and I'm going to place the end of my pen where x is -4 on the ordered pair. X is -4. X is -4. Oh, well, there it is right there in the curve. It turns out to be at the vertex. So they're asking, because it's f, they're asking what's the y value when x is -4? What's the y value? It's -2 when x is -4. So when x is -2, oh, right here, don't put it on the x-axis, put it up where the curve is. When x is -2, the y value looks like it's 2. Different image. Is it a function? Yes. Kind of a weird looking function. The last one was a parabola. See over here? That's the name you probably would have given this. It's called a parabola. That happens to be quadratic as well. Quadratic is a degree 2 polynomial. That's a quadratic. We're going to have a whole section on quadratics down the road. I think it's chapter 2. Okay, so if I were going to give this a title of a function, and we're going to look at it in this semester as well, it's called a piecewise defined function, piecewise, because I can look at it in little pieces. There's a line, that's a piece, and there's a different line. They're all lines, and there's another line, and there's another line. So I see 4 different little lines. It's a piecewise defined function. Now the domain, again, is from left to right. How far left to how far right. It looks like it stops right here or starts right there. You see that's an open dot. So this is the origin down here. 1, 2, this is -3 right here. So for the x values, this is your x-axis and this is your y-axis. The x values, it looks like it's -3. Because it's got an open dot, you're going to go parentheses -3. Now I'm looking along here, along the curve. Is there any breaks or holes? No holes, no breaks. Holes would be like an open circle. No breaks, no holes. All of a sudden there's a break. There's a break. So right now the domain would be all real numbers from -3 all the way up to whatever this is, 1, 2, 3, 4, 7, 8. Okay, so far I'm up to 8. Now I get a value up here, but I don't get a value down here, which is actually a good thing, because otherwise it's not a function. This is still a function because it passes the vertical line test. But Jeff, it went through D and E. Well, it really doesn't go through E because it doesn't exist. So it is a function. So right now, it's like if I wrote this is a parentheses all the way up to 8. And there might be a bracket. And then once I pick it back up again, you might do a union. That means union. Okay, continue like an or. More about unions later on. There's also another symbol that looks like this. Intersection. Okay, where do I pick it back up? I pick it back up at 8. Now think about it. I get 8 and I don't start at 8 anymore. So I could have just continued, which is a nicer way of looking at this for domain. I'll show you what the result looks like. But if I pick it back up at 8 and I go all the way to infinity, the best way of writing this is -3 all the way to infinity. Because I'm not excluding anything, not even 8. See, I pick up 8 right here. That's the best looking answer.
Jeff, we have a question about brackets versus parentheses.
Yep. Okay, so if you got an open circle, I'll abbreviate, it's parentheses, and if you got a closed circle, it's a brack. If you took SRJC's beginning algebra or intermediate, I can't think, well, our beginning algebra text, everybody has to use, it uses parentheses and brackets. It does. It introduces you to the interval notation. You just may have forgotten. What else? If I had an inequality that looks like this, and you graphed it on a number line, again, everybody should have had this kind of concept in an algebra class. You would have probably done like something like this in high school. They might still do little open circle, closed circles. What we do is parentheses for this. And the parentheses you use, because there's 2 different parentheses like that, the one you'll use is the one that opens up to the left in this case. You're going to use this one. So the best looking picture would have been like that instead of the open circle. And if you were going to give an interval notation for this right here, you'd have negative infinity from the left all the way up to -1 from the right. That would be interval notation. So the range is low to high. The range is the y. See, B is the lowest on the graph. So what's the y value at B? What's this value right there at B? Well, -1. That's -2 the way I'm reading it, because that's the origin right there. The lowest y value is -2. Now, because it's a solid dot, it's got to have a bracket. Well, okay, bracket. How about that, Jeff? That looks weird. That's weird. No, you want the bracket the other way. No, that's really weird. You want the bracket this way. Okay, comma. And then how far do the y's go? Well, let's see, the y's are going up to here. Oh, okay, now they're back down here again, but they continue up. Looks like the y is going all the way to infinity. The y is going forever. This says you get every single y between -2 and infinity. Really, Jeff? How about 4? You get 4, y value being 4. Well, let's see if we can find it. 1, 2, 3, 4. Okay, so here's 4. Yeah, you get it right there. Y value is 4. Oh, you also get it over here somewhere. Jeff, I thought functions, you have a problem if you have multiple y values. You do have a problem if you have the same x and multiple y values. This is just saying a y value. It passes the vertical line test. So that's where it would be a problem, like a circle right here. Same x value right here, but 2 different y values, same x value. That's not our picture up here, not at all. Okay, x-intercepts are about, so I'm going to go, instead of ordered pair, I'm going to go squiggle, squiggle. That looks like about negative 1.7. That's about negative, it's going to be positive 0.4-ish. Y-intercept is about negative 0.5 maybe. F of 5. Okay, so I'm taking the end of my pen and I'm looking for X to be 5. Where is the X5? 1, 2, 3, 4, 5. Here's 5. So I'm going to put my pen at the place on the curve, which is right there at C. So it's asking, what's the Y value when X is 5? What's the Y value when X is 5? Okay, there's 5. It looks like over here, 4, 5, 6, 7. So it looks like that's going to be 7. And like manner, when X is 7, okay, that's 7 right there. So put my pin right here where X is 7. Oh, hey, the Y value is the same thing. It's going to be 7. Okay, when X is 8, okay, put my pin, well, shoot, do I put my pin at D or E? D or E, or do I put it at both? Well, I'm going to put it at D because that's where the dot is. This is open. Oh, okay, so my pin is right there at D. F of 8 should also be 7. Okay, negative 3. I'm going to go over here, negative 3. Okay, put my pin. Oh, it's at A. Oh, there's an open dot. So you're going to say, I don't know. I don't know. Undefined is the best answer. Undefined. Right on time. Last problem, something like it. Let's see, h of 0. Oh, is it a function? Yes, it is. Yes. Yes. Okay, h of 0. Okay, so here's x to be 0. What's the y value? It's 2. H of 1, here's, okay, not going to stop there. You're going to be here. H of 1 is 2 as well. H of 3, well, it's got to be somewhere around here-ish. It looks like it's 3. I'm going to say it's about 3, squiggle. Hard to see on my graph. Okay, h of negative 2, wouldn't that be over here? Well, it's still going to be, this is assuming the arrow goes this way. That's still going to be 2. And h of 6, I'm just going to say it's about 6 because it's going to be off. I'm going to say it's about 6. So 1.2 should be like that. I'm looking in the homework section for 1.2. Well, here's, similar kind of problem I just did right here. Here's your picture and answer those questions. Similar kind of problem. Okay, instructions for the next ones here. It says, what's the domain? What's the range? What are the x-intercepts and the y-intercept? And then do some other stuff. So if I look at this one, well, let's do this one. Look at this one. What's the domain? Well, the domain starts from, looks like 0 and it goes forever to infinity. 0 would have a bracket. What's the range? Well, the lowest right here is also at that dot. So it looks like it's positive 1 with a bracket all the way to infinity, parentheses. What's the x-intercept? You'd say There are no x-intercepts. What's the y-intercept? Well, you'd say y equals 1. And then what's f of 4? You'd say f of 4 is right about there. It looks like it's 3. F of 4 is 3. All right, so you get a few of those. Here's some questions about whether they're functions or not. Let you kind of look at that. This one here, it says evaluate. So that means what's f of 6? You stick in a 6 and come up with an answer. You stick an x plus 1 in for x. Don't forget to put parentheses around that and simplify. And you put in negative x for x and simplify. So we've done some problems like that. And that's it. I did it. Pretty good timing. Look at that. 3 minutes, 3 minutes after. If I didn't have to shut down the computer, I would have been spot on. Exactly 10 o'clock. All right, now what I'm going to do is set this thing up so you see what is in your Canvas. Let's see, dashboard. So if you go into Canvas right now, I'll show you here from my perspective. If you go into Canvas, I'm going to go in as a student so you see what I'm seeing. Go into assignments. And right here, it's called daily quiz number 1. A little airplane means it's up and running. So if I click on that as a student, and it says take the quiz, you click on that, and you've got some problems here. So 4 problems. Okay, now anybody not able to see it in their Canvas? Anybody not able to see the daily quiz in their Canvas? Okay, nobody's saying anything. That means you all found it. So I'm going to put you in groups of 2. You'll have at least 1 person with you. There might be 1 group that will have 3. And you get to work on this with a partner. You can agree or disagree on the answer. It doesn't matter because you're taking it in your own Canvas page. And then when you're done, that's all I have for you. Bonnie will be in the her Zoom session as soon as we're done talking right here. I'm done talking. And she'll be waiting there for anybody who wants to join her. Otherwise, you can stick around and ask me questions about homework or the lecture today. If you've never done to a what's called a breakout room, I'm going to set that up, and you're going to get an invitation into the breakout room in about a minute. Let's see. Yeah, it's not going to work. Okay. Okay, yeah, there's 1 room that has 3 people in it. Now I'm going to click open the rooms, And all you do is say join, and then you go ahead and hang out with your person. If you need my help, come see me. So Bonnie, whatever you want to do, they're going to be a few minutes in their own rooms. And then hopefully you'll get a bunch of them coming to you today, and a few just hanging out with me.
Sounds good.
Okay, see you later.
Did you have a chance to look at that question that I sent you?
Thank you. I did not.
Okay.
Can you remind me right now what it is so we can look at it at this moment?
Yeah, it was pretty simple. I think I just didn't quite know where to go with it.
Was it a textbook problem? Remind me of the textbook problem.
It was number 38. I ended up with the absolute value of -6 minus x over
Is this
negative 6
P7?
minus. No, this is 1.2.
Oh, thank you. And you said, which number again, 38?
Yeah, number 38, but, oh, part C. So I end up with the absolute value of -6 minus x over -6 minus x. So it's the absolute value function.
Yes, I see that.
In the rational, like the fact that it's the numerator, it's an absolute value in the numerator.
You want to show me? You have it worked out?
Let's see. Can you see that?
Yep, I see that. And now you want to know what you do with that?
Yeah, exactly.
So you could factor out the negative in the numerator before you take it out. So go absolute value of -1 parentheses 6 plus x.
Absolute value of -1 is 6 plus x.
Yeah. So bars -1 times 6 plus x. And since it's a product, the absolute value will always turn everything into a positive. So really the negative gets absorbed.
Let's see, like that?
Yes, I agree. And was the denominator originally -6 minus x? Okay. So the negative in the absolute value turns out to be a positive. And then you'll be left with 6 plus x.
Okay.
All over -6 minus x. Now, because you don't know what the value of x is, I think at this stage, that's all you can do.
Well, it basically says that you end up with 2 answers. You end up with, like, when x is greater, it goes one way.
Oh.
And then when x is less, it goes the other way. So I just algebraically wondering how you would get to that.
Yeah. Yeah. So let me show you that. The definition of the absolute value. Okay, that's your formal definition of absolute value no matter what. Okay. So if you had absolute value of, was it -6 minus x, like that?
Yeah.
Okay, equals. Drop the bars. That's basically what they're saying is drop the bars. Let's see if I can do this right. If -6 minus x over -6 minus x, if x is greater than or equal to 0, and then it's the opposite of whatever's inside here. So it's the opposite of the numerator So that should be maybe, it looks like it's just going to be 1 each time if x is bigger than or equal to 0. And this would be 6 plus x over negative 6 minus x. And that looks like it's negative 1.
Right.
Because you can factor off a negative down here, and then the rest of it cancels. So it looks like this is.
Okay,
And
so you just basically set it up as two separate equations
Yeah, the key
with
thing.
the definition of the absolute value of x.
Yes, yeah. And if you want to test it, you can say, well, I'll pick something that's like 5. So put a 5 in here. That's negative 11 over negative 11, and it's 1. Okay. Pick something that is negative, like negative 1. Okay, negative 6 minus mine. Okay, that would be negative 5 over negative. Oh no, let's see, negative 1. Oh, here, negative 1. So absolute value of negative 6 minus a minus 1 over negative 6 minus a minus 1. That's negative 5 all over negative 5, except the numerator becomes a positive 5.
Yeah. Okay. So I think I was missing the definition of the absolute value with the brackets and the x.
It's easy to forget. It's easy to forget that.
Okay. Well, that answers the question.
Okay,
Thank you.
you're welcome.
All right. I'll head off to my Zoom room.
Sounds good.
See you later. I hope everything went well with your move.
It did. Thank you. I'm glad that it's done. It's done.
I've had.
Yeah.
Yeah, moving is a lot of work. That's
Okay.
all I remember about moving is it's a lot of work and it tends to be very expensive, no matter like what you're doing.
Yeah, that's
Always
true,
expensive.
because the movers, I thought, oh, it'll be $800. Well, at the end, it was actually 13 at the end. But I was happy with young guys. I didn't have to move a darn thing, and it was worth the extra money that I had to spend for certain things. So I was glad.
Yeah. Yeah. So you got a good value then.
Yeah.
All right. Well, I'll see you next time.
Yeah.